Hello everyone, welcome to session 28 of Theory of Computation or Formal Languages and Automata Theory. So in today's session, we are going to discuss about the functionality of pushdown automata. We will consider few problems and we will try to construct the pushdown automatas for those problems or for the given language properties. Okay. We will also discuss how to represent the language acceptance of pushdown automata in a mathematical way. So let us have a look. So these are the concepts which we have seen in the previous session. We discussed about the pushdown automata. So pushdown automata is nothing but a finite automata with an auxiliary memory called stack. So we are having the finite automata along with a stack, right? So by adding that extra memory or by adding that extra data structure called stack, we can able to accept more languages than the finite automata, right? So that is the reason that the pushdown automata will accept uh, more languages than the finite automata, right? So the language which is accepted by the pushdown automata is context-free language. Okay, and we have seen the model of pushdown automata that is having the input tape, finite control, and along with that we are having a pushdown store or a stack. Okay, and we discuss how these three components will communicate with each other to process the given input string. Okay, so this is the concept which we have seen, and then we discussed about how to represent the pushdown automata in a mathematical notation. The pushdown automata can be expressed as a tuple of as a seven tuple. So we are having m is equal to q comma sigma comma tau comma delta comma q naught comma z naught comma f. So we are having the seven tuples here. So q is the finite set of states, sigma is alphabet set which consisting of finite set of input symbols. Tau is nothing but finite set of stack symbols or push down symbols we can call. Transition function, we already discussed this. It maps current state and current input along with the stack symbol to produce next state, and it also writes some string onto the stack, or it also writes some symbols onto the stack, which is the part of tau star. Okay, and q naught is the initial state of the pushdown automata. Z naught we are considering as it is a special symbol that represents the bottom of the stack, right? So initially the stack consisting of a symbol z, right? So bottom of the stack symbol, we are representing that bottom of the stack with a symbol z naught, and f is nothing but a set of final state, right? So set of final states is nothing but the acceptance states that we are having. So final states will be subset equals to set of states q. Okay, so these are the seven tuples that we have seen. Next one is instantaneous description. We discussed the importance of this id. So at a particular instant of time, the configuration of pushdown automata can be represented by using this id, instantaneous description, and it is going to have the three components. It represents the present state or current state. Second one, the string that is to be processed, and next one is contents of the push down store or contents of stack. Okay, so if we consider here, we are having this instantaneous description which is representing that we are in state p, and the input string that is to be processed is ax, and the stack contents are z alpha. Okay, so whenever we are writing this instantaneous description in this way means we are in state p, and in that state we are considering the input symbol a and the stack symbol z, right? So the moment when you consider the stack symbol z means it is popped from the stack, right? So here in state p, on considering the input a and stack symbol z, where it is going to the state q, so that we are writing v dash, it is going to state q comma, what is the remaining input that we have to process after a, that is x, so that part we are writing, okay, x, and then comma. Afterwards, by considering this transition function, it is clear that we are going to the state q, and we are going to push the symbol gamma onto the stack, right? So gamma, so already alpha is there in the stack, so just we are pushing that gamma onto the stack. So now if we consider the stack content, it is gamma alpha. Okay, So that is how we will write this instantaneous description. So we considered one pushdown automata here, and we tried to represent it in a ID format, instantaneous description. So here, if you observe, there is a change with respect to this finite automata and this pushdown automata. So here in pushdown automata, generally with respect to the transitions, we are going to have two tuples. The one is that, sorry, we are going to have this only one tuple in finite automata. That means we will consider the state, and from that state we specify the transition on input symbol, right? So we are going to have only one component that belongs to the transition, right? What is that component? Input. But here in the pushdown automata, we are going to have the three components related to the each transition. So the first component is the input symbol, okay, comma. The second component is the stack symbol, okay, slash. And this part, after the slash, we are writing the strings that are to be pushed down to the stack, right? So we are having the three components here. So first component is the input symbol. Second component is the stack symbol that we are considering, okay, and slash means we are specifying the string that is to be pushed down to the stack. So here by seeing this q naught on a, that means q naught on a comma z naught, that means if you are in state q naught, if you process a and z naught, you will be in the same state because self transition is there, slash, and the string that is to be pushed onto the stack is a z naught, right? So this is a z naught slash, after slash whatever you are writing means it is the string that you are interested to push onto the stack, or the string that you are pushing onto the stack. So a z naught must be pushed onto the stack. So as I mentioned that while pushing, you should push in such a way that a must appear on the top of the stack, right? So you have to push z naught first, and then followed by that you are going to push a, right? So you have to push the string such a way that this leftmost symbol must be on the top of the stack, right? So a must be on the top of the stack. So that is the meaning. In finite automata, every transition has only one label. What is that? It is input. But here the transition is going to have that three components, right? The first component is input symbol, second component is stack symbol, slash, and the third component is this one string that we are pushing onto the stack, right? And next again we are having the transition q naught on a, okay, on input a comma stack symbol a, you will be in same state, okay. So q naught on a comma a, you will be on q naught only, slash what you are going to write onto the stack a, okay. So this is how we are going to specify the transition, right? Then q naught on b comma a, q naught on b comma a, we are going to state q1, and what we are writing? We are writing nothing onto the stack. So just means we have to specify epsilon. So we are pushing epsilon, or we are pushing nothing onto the stack. That it means, okay. Q1 on B means you will be in same state. Okay, Q1 on B comma A, you will be in same state, and you are going to push epsilon onto the stack. So that's why we are having slash epsilon. Okay. Next Q1 on epsilon, Q1 on epsilon comma Z naught. That means the input is epsilon and the stack symbol is Z naught. So Q1, in Q1, if you see these two symbols, you're going to state Q2 and you're going to push the Z naught onto the stack. Okay. So this is how we interpret the pushdown automata, right? Now this is how we specify the instantaneous description. So initially we are in state Q naught and we want to check whether AB is accepted or not. So this is the AB is the string, and initially I mentioned that the stack consisting of Z naught, right? So the initial configuration of pushdown automata will be represented as Q naught comma AB comma Z naught, right? And next, by considering this state transition diagram, you could find that in Q naught on input A on stack symbol Z naught where you are going. So Q naught on A comma Z naught where you are going. So A comma Z naught means you are in the same state. So Q naught you have to write. So Q naught comma, what is the next symbol that we have to process after A? That is B. Okay, B comma, what you are pushing onto the stack? We are pushing A Z naught, right? So that will become the stack content in the next ID value. So A Z naught, right? The next one, consider the state Q naught, input B and stack symbol A, and check out the transition. So Q naught B comma A. So Q naught B comma A, where it is going? It is going to state Q1. Okay. After B, what is the remaining input that we have? Nothing. So that is represented by epsilon. Okay. Then what we are writing onto the stack? That what we are writing onto the stack, we are writing epsilon, right? So we are writing epsilon means what will be there in the stack, it is z naught only. Okay, since we have popped a, we processed it and we haven't pushed anything, so epsilon, that means we pushed epsilon. So anyhow we pushed epsilon means the top of the stack will be z naught itself. Okay, now you are in state q1, the input is epsilon, the next that means the stack symbol that you are considering is z naught, right? Okay, so I mentioned you that whenever we are considering this stack symbol, consider that we have popped it, right? So in this scenario here, q naught comma epsilon comma z naught, so we are considering z naught from the stack means it was popped from the stack already, right? So now check it the transition for q1 on epsilon comma z naught. So q1 on epsilon comma z naught, where it is going? It is going to the state q2. So next id will have the state q2 comma, what is the remaining input that we have to process? Nothing, that is epsilon. And then what we are pushing onto the stack, so we are pushing z naught onto the stack, so the z naught will be the stack content, right? So if you observe, we don't have anything to process here. Okay, and here this one, we reached the final state q2, we reached the final state q2, so the string ab is accepted, right? So here in a shorthand notation we could write like this, q naught comma ab comma z naught, that means processing q naught, processing ab from q naught with stack symbol z naught in one or more steps, we are going to get q2 with stack content z naught. Okay, so q2 belongs to the final state, so the string is said to be accepted. Okay, like this. Now, so let us discuss the scenario. Design a PDA for the language A power n, B power n such that n value is greater than or equal to 1. So this is the language for which we have to design the pushdown automata. Okay. So the first thing is that whenever the language is given in this equation format or defined as a function, just try to write down the set of strings there by considering the given property, right? So here we are having L is equal to set of A power n, B power n such that n value is greater than 1. So substitute each value of 1, okay, in place of, so substitute each value of n in place of n to get the different strings, right? So A power n, B power n. So first take n value as 1 and substitute in place of n to obtain the first combination. So A power n, we are considering n value as 1 means A power 1, B power n. So we are going to get the string AB. Okay. Now consider n value is equal to 2. So you'll get A square, B square. A square, B square means 2A, 2B. Okay. Next one, consider n value is equal to 3. You will get 3a's followed by 3b's. N value equal to 4. 4a's followed by 4b's, right? So here, by seeing this language property, we could say that the number of a's and number of b's must be the same, right? So how do we implement a PDA that will accept such language, right? So here the logic is that the number of A's and number of B's must be the same, right? So such type of strings will be accepted, right? So to implement the PDA for such languages, so here first thing is that as long as you see a symbol small a, push it onto the stack. Okay, so whenever a string is given, so in that string while processing the each input symbol, whenever you see a small a, push that small a onto the stack. Okay, so let me say I am having something like 2a's 2b's, w is equal to a square b square, that is a b b, right? So what is the top of the stack? Initially it is z naught, right? So just now I mentioned the initially the top of the stack or that is represented by z naught. What is the first symbol that we are having? A. So when you get a, push that a onto the stack. Okay, so done. What is the next input that we are having? A again. Since it is a, push that a onto the stack. So you are going to have z naught a a. what is the next input that we are having? B. So the moment when you get a small b, pop the stack. Okay. So what is your input symbol here? B. So the moment when you get B, pop the stack. So once you pop the stack, what is there that is going to be come out of the stack? That is A. Okay. So just pop the stack. Okay. Then next, once you pop the stack, what is the content of the stack? Z naught A. Okay. And the next input is B. Okay. So what happens if the next input is B? Again pop the stack. Okay. So done. What is the next input that we are having? Epsilon. That means epsilon means we are not having anything to process. So epsilon in the input represents end of the input, right? And what is the stack content that we are having? Stack content that we are having? Z naught. Okay. And if we are in the final state after performing the step 5, okay, after performing the step 5, if we are in the final state, then the string is said to be accepted. Okay. So that is how we can implement the logic of accepting the language A power n, B power n, right? So here we have to make a comparison between the number of A's and number of B's. So how do we are making the comparison means whenever we see a symbol small a, we have to push it onto the stack, okay? And whenever you see a B symbol, pop the stack, right? So at the end of this input, if the stack consisting of Z naught only, okay, if the stack consisting of Z naught only, then the string is said to be accepted. Okay. So let me explain the controversial case here. A, B, B, B. So this logic must not execute for this particular string because this is the string which does not belongs to the language, right? So let us check our logic. So the first symbol is A. So push the symbol A onto the stack. So we are having the stack content Z naught followed by A. Okay. Top of the stack is A now. What is the next input? We are having A. So push that A onto the stack. The stack content will become Z naught A. Now what is the next input? B. So the moment when you get B, pop the stack. So will pop the first A. Okay. Next input is B. Pop the stack, that is A. What is the next input? B. Okay. And what is the stack consisting of? Z naught. Okay. So if we don't have the transition for this case where we are having input symbol and Z naught onto the stack, then it indicates that the string is not accepted, right? So if we don't have the transition for this, that is from a state on input symbol B and on Z naught, then that particular string is going to be rejected by the pushdown automata. Okay. So Z naught must be there onto the stack when your input symbol is epsilon. Okay. So then only the string is considered as an accepted, right? So if we observe the previous case, we end up with input as epsilon and top of the stack as Z naught, right? Since the input is epsilon and the top of the stack that we are having is Z naught, right? The string is said to be accepted. But here if you observe, we are having the input symbol B and top of the stack as Z naught, right? So that should not be the case. And if such type of scenarios happen, then that particular string is going to be considered as rejected. Okay. So we will examine these things closely when we discuss the problems related to pushdown automata. Okay. So just for time being, just assume that we have to implement the logic in this fashion. Okay. Okay. So this is how we can specify the state transition diagram for this particular problem, right? So how what we have done here, we have taken the input, and whenever we see this A, we have to push it onto the stack, and whenever we see B, we have to pop from the stack, right? So by this logic, we have to implement the state transition diagram. So we will start with the state Q naught, okay? So start with the state Q naught. So Q naught is representing that we are seeing A. Okay. Okay. So Q1 is representing the state that we have seen B. Okay. And Q2 is the final state. So that is the reason I have taken the three states. So as long as I will get A, I will be in the state Q naught. The moment when I get B, I am going to the state Q1 because Q1 is representing that we have seen the input symbol B, and Q2 means it is representing that we have processed the entire input string, and we reached the final state, right? And the string is considered as an accepted. Okay, so Q2 is representing the final state, right? So let us consider the scenarios. So first, initially, the stack content will be the Z naught, right? Stack content will be Z naught. And what is the input that I am considering here is, let me call it as AABB. Okay, AABB. So this is the input which I am considering, right? Okay, right. So I am starting from the state Q naught, right? I am starting from the state Q naught. Q naught is representing that I have seen A. Okay. Now in Q naught, what is the first input symbol? A. Okay. And what is the stack symbol? Z naught, right? So when we are considering Z naught as a stack symbol for processing, assume that it was already popped from the stack, right? So assume that it was not in the stack, it is outside the stack. Okay. So the moment when we read the stack symbol, consider that it was already popped, right? So now what is the configuration now we are having? You are in state Q naught, the input symbol is A and the stack symbol is Z naught, right? So what happens? So since we got A in the input, what we have to do? We have to push that A onto the stack, isn't it? We have to push that A onto the stack. While pushing, you have to push in that way such that Z naught will be pushed first and then followed by A, right? You may get a question, sir, why we are pushing the Z naught? I already mentioned that the moment when we are considering the Z naught initially from the stack means it is out of the stack. Okay, so in order to stop our processing, we have to complete the all the input symbols and we must get Z naught onto the stack at the end, isn't it? So that is the reason we are pushing the Z naught again followed by A. Okay, so that is the reason. So Q naught on small a on stack symbol Z naught, where you will be in state Q naught. Okay, you will be in state Q naught. So let me write Q naught on A comma comma Z naught Z naught, we will be in same state Q naught slash what we have to push onto the stack, we have to push A, but before A what we have to push, we have to push Z naught. So we have to write like this slash A Z naught. So what happens after executing this step? What happens? The stack content will consisting of Z naught followed by A. Okay, now what is the next input symbol that we are having? A. Next input is A. Now what is the top of the stack that we are having? A. So here, see, here the input is A, top of the stack is A. So what happens if the input is A and top of the stack is A? What happens? Since the input is A, we have to push that input onto the stack and we will be in the same state, right? So as long as we see A, we will be in the state Q naught. Okay. So you will write state Q naught. Okay, you will be in state Q naught. What is the input that we are having? Small a. What is the stack symbol that we are considering? A. So I mentioned that whenever we are considering the top of the stack for processing means assume that it is already out of the stack, right? So now what we have to push onto the stack? We have to push A. We have to push A. You may get a question, sir, why we are pushing two A's instead of one A? The reason is that when we consider the top of the stack, that is A, where it was out of the stack, isn't it? Now to push this new input A, before that what we have to push? We have to push another A, right? So that is the reason we are pushing the two A's. Okay, so that's why we are having Q naught on A comma small z slash az naught, we are having on same state Q naught. And another case is that if the input is A and the top of the stack is A, means you will be in the same state and you are going to push A. Okay, you are going to push A. Okay, why? Because all the A's must be onto the stack. But here what we are doing, we are considering the top of the stack A Since we are considering this A from the stack means it is out of the stack, so we need to push it again, right? So that's why we are writing AA. That means previous A, new A. Okay. So this process will continue as long as we will get A in the input, right? Now, so let me consider here, come back to this point. What is the stack content now? Z naught followed by A followed by A. So this is the stack content, right? Now what is the next possibility? What is the next possibility? If we get a B, if the next input symbol is B, so next input is B. So what would be your stack content? It is A, right? So definitely the next possibility is that when the moment you get B, the top of the stack must always be small a only, right? So once you get a small b as a input, we have to move from state q0 to q1. Okay. So as long as you get A, you will be in state Q0, right? The moment when you get B, okay? The moment when you get B, so what we have to do? We have to move from state Q0 to Q1. Why? Because Q1 is representing the B, okay? Is representing that we have seen the symbol B, right? So now what we are writing in state Q0 on seeing B and input symbol A slash what we have to push, what we have to push. So already I mentioned that whenever we see small b, we have to pop the stack and we need not to push anything. So that's why we are writing slash epsilon, slash epsilon. So what it means, on seeing b and stack symbol small a, we are going from state q0 to q1 and we are not pushing anything. So that's why we are writing epsilon. Okay. So if you consider this diagram in left side, you could see q0 on small b comma a slash epsilon, it is going to state q1, right? So whenever you are mentioning slash epsilon means it is indicating that you are performing pop operation, right? So you are performing pop operation and we are not pushing anything. Okay. So as far as our logic is concerned, whenever we see this B, we have to pop the A. So we should not push anything. Okay. Next thing. Okay. Next configuration, if you observe, if you get a next input symbol B, the top of the stack must be A, isn't it? So in Q1, if you get a B input symbol again and top of the stack is A means you will be in same state Q1. You will be in same state Q1. What you are pushing onto the stack? Nothing. That's why slash epsilon. So on seeing B, what you are doing? We are popping A. Okay, and we are not pushing anything. So that's why we are writing slash epsilon. Okay. So we will be in Q1 as long as we will get B as a input and top of the stack will be A, and we are going to push nothing onto the stack. Okay, that's why epsilon. Right. So at the end, so end of the input is represented by epsilon. Okay, so see here in the right side, after processing 2 bits, what is the next input that we are having? Nothing. So nothing means epsilon. Okay, now what will be the stack content? Epsilon comma what will be the stack content? It is z naught, right? It is z naught. So if we don't have anything to process, that is epsilon, and you are going to have top of the stack as z naught, then what we are going to do, since we are not having anything to process and top of the stack is z naught, we could say that the string may be accepted. So that's why we are moving from state q1 to final state q2. Okay, so we are moving from q1 to q2. The q2 is the final state, right? And what we are going to push in this scenario, we are going to push z naught, right? We are going to push z naught. Why? Because for comparison we popped z naught, right? So the input is epsilon and stack content is z naught, right? Now what we have to push onto the stack? Z naught, because z naught must always be there into the stack, right? So that is the reason we are pushing z naught. Okay, so that's why here we represented the transition like q1 on epsilon comma z naught slash z naught, it is going to the state q2. Okay, right. So how do we define the transition function? So the transition function we defined by writing like this: delta of q naught comma state. This is the state. This is the input symbol sigma. This is the stack symbol tau. And what we are going to get? We are going to get state along with tau star. Okay, stack symbols. Okay, right. So Q naught on A comma Z naught, where we are going? Q naught on A comma Z naught, we are in same state, Q naught. Okay, what we are writing? So to know this, you have to check the slash. That means the string that is written after the slash. Okay, what is written after the slash? A Z naught. So A Z naught must be written here. Okay, then Q naught of A comma A. Q naught input is A, stack content is A. So where you are going? You are going to the state Q naught itself. So Q naught comma, what is the stack content that you are writing? A. So that you have to write. Okay. Next Q naught on B comma A. Q naught on B comma A. Where it is going? It is going to the state Q1. What you are writing onto the stack? Epsilon. Okay. Then next one Q1 B comma A. So delta of Q1 comma B comma A means you will be in state Q1, and what you are pushing onto the stack? Epsilon, nothing. Okay. Next Q1 on epsilon comma Z naught. So delta of Q1 comma epsilon comma Z naught. Where you are going? You are going to the state Q2. What you are writing onto the stack? Slash Z naught. So Z naught you are writing. Okay. That's it. Now, so if we represent this entire pushdown automata in tuple notation, we have capital Q is equal to Q naught comma Q1 comma Q2. So Q naught comma Q1 comma Q2. Sigma is equal to A comma B. It is from the language property. And tau you are going to have Z naught comma A. Why? Because Z naught is already there in the stack, and along with Z naught what we are pushing onto the stack, we are pushing A. Okay, so that's why we are having tau is equal to Z naught comma V. If you are pushing B means you could write tau is equal to set of Z naught comma A comma B, right? So whatever the symbols that you are pushing onto the stack, that will be considered as a tau. Okay, and F set of final state, we are having only one final state Q2, so that is considered as capital F. And next, what is the initial state Q naught? So it will be your Q naught only. Okay, initial state. So this is how we could design the pushdown automata, and uh, we can write the transition function and tuple notation. Okay. Next part, this is the most important one: language acceptance by pushdown automata. So language acceptance by pushdown automata. So to accept the given language, we can construct a pushdown automata that may have a final state. Okay, that means that accept the language by going through the final state. Or you may also construct a pushdown automata that accepts the language by empty stack. Okay, so there are two ways in which we can construct the pushdown automata for a given language. First one is we can construct the pushdown automata that accepts the language by entering the final state, or we can also construct a pushdown automata to accept a given language by empty stack. Okay, by empty stack. So here, let us see the first one, acceptance by final state. So let's consider that you are having a pushdown automata, capital M is equal to, these are the 7 tuples, Q gamma, sigma gamma, tau gamma, delta gamma, Q naught gamma, Z naught gamma, F. Okay, then then set strings accepted by the final state is defined by, okay, so L of M is equal to W. So what is the language of pushdown automata? The set of strings which is accepted by pushdown automata is called its language. Okay. So we are writing those set of strings. So set of words W or set of strings W that belongs to sigma star. That means the symbols from the strings are chosen from alphabet set sigma. So set of all words that belongs to sigma star such that on processing W from Q naught. Okay, so since we have to process W from Q naught, and by considering the stack symbol Z naught, in one or more steps, in one or more transition steps, or in one or more steps, if you get a final state QF, okay, if you get a final state QF, and the next input symbol is epsilon, that means there is nothing to process, and the stack consisting of Z naught or Z. Okay, if the stack consisting of Z or Z naught, then the string is accepted. That means such type of set of strings will define its language, right? So here QF is always belongs to set of final states, right? So QF is a final state. And what is this Z? Z is nothing but excuse me, tau star. Z is nothing but tau star. Excuse me. Okay. So next one, acceptance by empty stack. So here we are not going to have a final state, right? So the moment when you get an empty stack, the string is set to be accepted, right? So here you could see let m is equal to q comma sigma comma tau comma delta comma q naught comma z naught comma f be a Pushdown automata. Okay. The set of strings accepted by empty stack is defined by, see here, L of m is equal to set of all words belongs to sigma star, belongs to alphabet set sigma star, such that processing W Z naught from Q naught. Okay, so Q naught comma W comma Z naught means how do you pronounce it? Processing W comma Z naught from Q naught in one or more processing steps, you may get some state Q, some state Q. The input will be epsilon and stack will also be epsilon, right? So then such type of words, that means such set of words is called as the language of Pushdown automata, right? So if you observe the previous case number one, where we are reaching the final state, okay, after processing the input. But here we are reaching some state Q after processing the input and there is nothing onto the stack. So here we are having Q comma epsilon comma epsilon. So what is this epsilon? First epsilon, it is indicating that there is nothing to process, and epsilon, next second epsilon is indicating that the stack is empty. Okay. So such set of all words is called as language acceptance by empty stack. Okay. Language accepted by Pushdown automata by empty stack. Okay. So just remember these two. So we are going to construct the Pushdown automatas for both the things, right? So both the properties. So we are going to construct Pushdown automata with final state. We are going to construct the Pushdown automata with empty stack. Okay. So let us see the difference between these two ones. So consider the Pushdown automata for language a power n, b power n such that n is equal to n is greater than or equal to 1. So L is equal to a set of a power n, b power n such that n value is greater than or equal to 1. Okay. So this is the language for which we have to construct the PDA. We already have constructed the PDA for this just now. Okay. So just I am taking the Pushdown automata from the previous slide which we have constructed for this a power n and b power n. So this is the PDA, right? Now so which type of PDA it is? Acceptance by final state. Why? Because we are using the final state as Q2 because we marked the state Q2 as a final state, right? So this technique we can call it as acceptance by final state. Okay. So if you observe here, if you consider the ID Q naught comma AA comma B, sorry, Q naught comma AA BB comma Z naught, we are going to get Q2 Z naught. Okay, so Q2 comma Z naught. What is Q2? Q2 is a final state. What it means? That means on processing the string 2A's followed by 2B's from Q naught with stack content Z naught, we are going to get a state Q2, okay, with a stack content Z naught. Since the Q2 belongs to the final state, the string AABB is said to be accepted, right? So this is nothing but acceptance by final state, right? Now acceptance by empty stack. So acceptance by empty stack means here we are not going to have the final state, right? So for this strategy, we are going to have two states, okay, Q0 and Q1. So as long as you are going to get A, you will be in state Q0, okay, the same transitions. The moment when you get B in Q0, you go to the state Q1, okay, since the state Q1 is representing the symbols that B that we have seen. And as long as you are going to get B in Q1, you will be in same state Q1 only, okay. And then there is a small change after getting epsilon. That means if the next input symbol is epsilon and top of the stack is Z naught, you will be in same state Q1. Along with it, you are pushing epsilon here, right? So see here, we are pushing epsilon. In the previous case, what we have pushed, we pushed Z naught and then we move to the state Q naught, right? But here we are not having the final state. So what we are doing, we are pushing epsilon, right? So with a combination of epsilon comma z naught, we will be in same state q1 and we are pushing epsilon onto the stack, right? So this is called as acceptance by empty stack. Okay. So after processing the input, if your stack becomes empty, then the string is said to be accepted. Okay. So here in this case, how we will write the instantaneous description: q naught comma AABB comma z naught. In one or more steps you will get state q1 and the stack will be epsilon, right? So stack will be epsilon. So irrespective of the state, if you get an empty stack on processing the given input, the input is accepted. Okay, that input is said to be accepted. Okay, so this is for today's session. Okay, I hope this is these are the basic concepts and you have understood these concepts clearly. Okay, so just go through this concept once, practice this problem by considering acceptance by final state and acceptance by empty stack. Okay, in next session we will solve some more problems related to the PDA by using both the strategies. Okay, so thank you for attending this session. Have a nice day.